Hello, I'm Dr. Eben Alexander, and I want to share with you a wonderful new book that I'm helping to promote with its publication in the United States, October 14 of 2025. And I'm very captivated by this book, have become good friends with the authors. It's God, the Science, the Evidence, The Dawn of a Revolution by Michel-Yves Bolloré and Olivier Bonnassies. And they're both from France, and it's scientific proof of God, starting with origin theories to the present day. The book starts with a brief discussion of thermal death of the universe. That is, in the late 1800s, some information that suggested that entropy was always increasing, and therefore the universe would have an age, and there would be a thermal death of the universe. Now, you must remember that at the beginning of the 20th century, scientists thought the universe was in a steady state, and that is that it was kind of unchanging and would always appear to be about the same. And that was until 1929, when Edward Hubble, um, observed the galaxies were receding away from us. And in fact, the farther away they were, the faster they were going. And in fact, if you wind that clock backwards, you come to an origin of the universe. So what's been come to be known as the Big Bang. Um, and that's an incredibly important concept. Alexander Friedman corrected Einstein on the reality of an expanding universe in 1922. Georges Lemaitre, who was a Belgian priest, came up with a concept of a primeval atom and predicted Hubble's law in 1927. Fred Hoyle termed the term Big Bang poking fun at Friedman and Lemaitre in 1949. And by 1953, those supporting the Big Bang were defeated, at least until 1964, when the cosmic background microwave radiation was discovered by some Bell Lab scientists. The Big Bang, in fact, was the origin of space, time, mass, and energy. At the time, back in the early and mid 20th century, there were some alternatives to the Big Bang, but none of them ever really gained any real power. Tired Light from Fritz Zwicky in 1929, the Big Crunch and also Oscillating Universe popular in the 1970s, but none of these ever really caught on. That includes string theory and superstring theory from 1984 and later, which were not really falsifiable, so not really a scientific version of testable reality. Um, so we're really left with the power and experimental evidence supporting the reality of this, Big Bang and an origin to the universe. Board, Guth, and Vilenkin theorem in 2012 ended the Big Crunch and other arguments allowing no beginning. It's important to point out that Alan Guth in 1980 had offered up an inflationary model to really bring the Big Bang cosmology into reality and explain a lot of the current observations. Um, it's important to point out that this Big Bang concept back in the 1940s or so was very much opposed by both Soviets in Russia, the Soviet Union, and by Nazis in Nazi Germany. And at least 11 prominent scientists who supported the Big Bang cosmology were executed. And at least 5 of these scientists were forced into exile, including George Gamow and Albert Einstein. Now, a lot of the argument in the book is based on the fine tuning of physical constants in the universe. Things like the gravitational constant, the electromagnetic force, the fine structure constant, strong force coupling constant, weak force, speed of light, Planck's constant, which is essential for any chemical reactions, the masses of fundamental particles, et cetera. There are basically 26 or so of these fundamental uh, um, physical parameters of the universe. And in fact, the cosmological constant, which is something that's there to represent the expansion rate of the universe, is finely tuned to 1 part in 10 to the 120th. That's an extraordinary kind of fine tuning of its value to allow the universe to be as it is. Quotes from some of the major scientists commenting on this state of affairs. Lee Smolin from the Perimeter Institute in Canada said the probability that all these constants would be fine-tuned to allow for the existence of stars in the universe is 1 over 10 to the 229th power, which is an astonishingly rare possibility. John Lennox, a mathematician from Oxford, says the ratio of the electromagnetic force to gravity in the early universe had to be accurate to 1 part in 10 to the 40th. Robert Dicke, who was at Princeton in the 1960s, talked about precise predictions concerning the cosmic background radiation, fossil radiation, which is left over from the Big Bang, and realized that the extraordinary level of fine-tuning of these physical constants, the slightest variations of any of them, would have prevented space-time and life as we know it. So extraordinarily important, this notion of the fine-tuning. And Paul Dirac, who had formerly been a very militant atheist, a quantum physics Nobel Prize winner, said, God, and this is in 1963, he said, God is a mathematician of a very high order. And he used very advanced mathematics in constructing the universe. This fine-tuning is not the result of chance. That's what is so important to point out here. It appears that the universe has been very specifically designed so that we can exist, intelligent species, intelligent life. Basically, the mind of the universe gets represented in these beings that come into existence through the physical principles that we're talking about here. There's, at a bare minimum, the existence of life seems to require the existence of extremely complex structures at a variety of scales, ranging from galaxies to planetary systems, all the way down to macromolecules. Now, the multiverse is another theory that enters into this. And the question is it really a theory or merely a loophole? The multiverse theories function as escape mechanisms that distract us from the real metaphysical questions at stake, generally unfalsifiable fantasies that avoid the data. Now, biology is a beautiful field to study, to find other examples of this incredible intelligence. To me, one of the most fascinating has been the leap from inert to living matter. That is, the improbability of the first self-replicative molecule, RNA world. And I know when I was in training in science in the 70s and 80s, we used to think, well, you just don't know how long 1 billion years is if you can't imagine what can happen in biology over long time scales. But the reality is that the simplest life forms, DNA, proteins, ribosomes, enzymes, the 2 languages of DNA with 4 letters, A, T, C, and G, grouped in 3s, and then 22 amino acid letters to make up about 80,000 distinct proteins in the biological world. There's a translator, the ribosome, which at minimum requires 53 different proteins and 3 polynucleotides. So how are we to assume that somehow all of that structure would spontaneously form in a way that would be preserved long enough so that you could have a self-replicating molecule come out of it? The possibilities of that happening just by chance are almost infinitesimal. So practically speaking, it would take longer than the lifetime of the entire universe for a single protein to form by accident out of the available amino acids. The simplest life form of about 200 amino acids becomes far less likely, especially given the additional demands of unlikely formation of the related RNA, DNA, genes, enzymes, and many other factors involved in cellular metabolism. So some of the expert quotes that this book offers to kind of help flesh out this deep mystery. One from Mark Halaby, a physicist in 2009, he said the probability the first self-replicating molecule was sensitized by chance alone, the time it would take for a chance-based universe to accomplish this would be millions of millions times the current age of the universe. That's a very important observation. The probability of obtaining a universe containing stars at random is about 1 over 10 to the 229th. That's from Lee Smolin at the Perimeter Institute in 2001. The cell's macromolecular machines assemble spontaneously from their protein and nucleic acid components. This would be like cars automatically auto-manufacturing by merely tumbling their parts on the factory floor. That from a Johns Hopkins biophysicist named Sarah Woodson in 2005. The laws of physics are supremely fit for life, and the cosmos gives every appearance of having been specifically and optimally tailored to that end. There is indeed a deep and necessary connection between virtually every characteristic of the cosmic stage and the drama of life. This from Michael Denton, professor of biochemistry and genomics in 1998. The living cell is so complex, it suggests it could not have come together in stages, but rather emerged fully formed from nothing. The probability would be similar to a tornado blowing over a dump heap to create a functioning Airbus A320 out of scrap metal. That from Philippe Labro, a molecular biophysicist. Now, it turns out, also mentioned in this book, God, the Proof, the Evidence, is a survey done of all the 20th century Nobel Prize winners. And in particular, they compared, and the question here was, do you believe in God? And interestingly enough, 35% of the Nobel laureates in the natural sciences believed in God, 35%, but only 10% of the Nobel laureates in literature believed in God. So studying natural science seems to greatly support one's belief in God. So we can no longer believe that this is a conflict between science and spirituality, but realize how they both play a tremendous role. Now, the main arguments for God are really recent, since the 1960s. Early 1960s, the complexity of DNA and cellular intricacy, recognition of the improbability of life arising by chance. Then in 1964, the cosmic microwave background radiation, CMB, was discovered, supporting the Big Bang and allowing a calculation that takes us back to the origin being 13.77 billion years ago. 1980s, discovery of fine tuning of universal constants, which we've already discussed. In 1998, the thermal death of the universe, definitively proven. And then also in 1998, two groups, one in North America, one in Australia, discovered dark energy, that the expansion rate of the universe was actually accelerating for the last 5 billion years. That had never really been considered to be a possibility. And so these observations of type 1a supernovas, which are known as standard candles because they have a very identical luminosity. So when you see one, by noting its brightness, you can figure out how far away they are. And that's how these groups discover dark energy. The 70% or so of all the mass energy of the universe is contributing to the accelerating expansion of matter away from, the Big Bang. And then also the Bohr-Guth-Vilenkin theorem, arguing for the necessity of a beginning of the universe, which was first published in 2003. I would reflect back now on Einstein's belief. He believed in a God behind the origin of the universe, who we refer to as the Old One, not really the God of the Bible, but everyone who is seriously involved in the pursuit of science, Einstein said, becomes convinced that some spirit is manifest in the laws of the universe, one that is vastly superior to that of man. In this way, the pursuit of science leads to a religious feeling of a special sort, which is surely quite different from the religiosity of someone more naive. That's from Einstein in 1936. He also said, my religiosity consists of a humble admiration of the infinitely superior spirit that reveals itself in the little that we can comprehend of the knowable world. That deeply emotional conviction of the presence of a superior reasoning power, which is revealed in the incomprehensible universe, forms my idea of God, Einstein said in 1927. He also said, the fanatical atheists are like slaves who are still feeling the weight of their chains, which they have thrown off after hard struggle. They are creatures who, in their grudge against the traditional opium of the people, cannot hear the music of the spheres. This also brought up in this book not only Einstein's beliefs, but Gödel, probably the greatest logician of the 20th century. In fact, Einstein spent his last decade or so working at Princeton at the Institute for Advanced Studies, and said, my own work no longer meant very much, but he came to the Institute for Advanced Studies merely to have the privilege of walking home with Gödel. So why is Gödel so important? He's famous for his incompleteness theorems, published in 1931, that revealed there was no mathematical system that could be completely proven without reference outside of itself. I think a similar argument can be made about human consciousness and trying to come to the depths of understanding what that really is all about. The notion of truth to Gödel was much broader than the notion of demonstrability in mathematics. Like Penrose's demonstration of non-computable algorithms available to the human mind that could never be derived by a computer, Penrose attributed this ability of mind as dependent on the Platonic realm, which is beyond the reach of computers. And Gödel felt that either the human mind is a reality independent of the material world, or mathematical objects have a reality outside of the material world. And Gödel thus saw, even back in the 1950s, the end of materialism. He fully believed in the power of intuition, given that his wife, Adele, had an extraordinary ability to guess playing cards without seeing them, far better than chance would suggest. He observed that the regularity and order of the world showed it all to be very rationally arranged. And in fact, Gödel wrote a proof of God's existence using modal logic, beginning with St. Anselm's ontological argument, with a logic supported by many mathematicians, but it was only published 9 years after his death. Gödel said that Einstein's religion is more abstract, like that of Spinoza and Indian philosophy. Gödel's, he said, mine is more similar to church religion. Spinoza's God is less than a person. Mine, that is Gödel's, is more than a person because God can't be less than a person. Gödel also said religions are, for the most part, bad, but religion, capital R, is not. I think we could now replace that word with spirituality in the modern era. Science practiced at the highest levels led some scientists towards God, not away from him. And I love the quote from Werner Heisenberg, who won the Nobel Prize in Physics in 1932, where he said, the first gulp from the glass of natural sciences will turn you into an atheist, but at the bottom of the glass, God is waiting for you. Now, there are supplementary lines of supporting evidence that support this book, God, the Proof, the Evidence, and they're prominently found at the bigelowinstitute.org website in the form of 29 scientific essays supporting the reality of the afterlife, that is, consciousness beyond bodily death. Now, notably, the second place winner of those 29 essays was Dr. Pim van Lommel, who concludes in support of the one mind. He won the second place prize. And he said that in support of the one mind we all share, he recommended 4 current scientific resources. First, the book One Mind by Larry Dossey, published in 2013. Also, Spiritual Science, a book published by Steve Taylor in 2018. A paper written by Bernardo Kastrup, The Universe in Consciousness, and that was published in the Journal of Consciousness Studies in 2018. And finally, Pim van Lommel recommends Living in a Mindful Universe, the book that Karen Newell and I wrote back in 2017 as a major scientific resource on this notion of the one mind that we're all sharing. I would add to that Pim van Lommel's book, Consciousness Beyond Life, published in 2010, is also a very rich resource in discussing these scientific realities. So there's a new scientific paradigm allowing us to move beyond the bleak and paltry fiction of materialism. The revolution uniting science and spirituality has begun.